The M109 is an American 155mm self-propelled howitzer, first introduced in the early 1960s. It has been upgraded a number of times, most recently to the M109A7. The M109 family is the most common Western indirect-fire support weapon of maneuver brigades of armored and mechanized infantry divisions. The M109 has a crew of 6, the section chief, the driver, the gunner, the assistant gunner and 2 ammunition handlers. The gunner aims the cannon left to right, the assistant gunner aims the cannon up and down. The M109A6 Paladin needs only a crew of 4, the commander, driver, gunner and an ammunition loader. The British Army replaced its M109s with the AS-90. Several European armed forces have or are currently replacing older M109s with the German PZH-2000. Upgrades to the M109 were introduced by the US and by Switzerland. With the cancellation of the U.S. Crusader and non-line-of-sight cannon, the M109A6 will remain the principal self-propelled howitzer for the U.S. for the foreseeable future. History: the M109 was the medium variant of a U.S. program to adopt a common chassis for its self-propelled artillery units. The light version, the M108 howitzer, was phased out during the Vietnam War, but many were rebuilt as M109s. The M109 saw its combat debut in Vietnam. Israel used the M109 against Egypt in the 1973 Yom Kippur War and in the 1982 and 2006 Lebanon Wars. Iran used the M109 in the Iran-Iraq War in the 1980s. The M109 saw service with the British, Egyptian and Saudi Arabian armies in the 1991 Gulf War. The M109 also saw service with the U.S. Army in the Gulf War, as well as in the Iraq War from 2003 to 2011. Upgrades to the cannon, ammunition, fire control, survivability, and other electronics systems over the design's lifespan have expanded the system's capabilities, including tactical nuclear projectiles, cannon-launched guided projectiles, rocket-assisted projectiles, family of scatterable mines, and improved conventional munitions. Design: the M109 was developed by the Ground System Division of United Defense LP. Armament: primary, M126 155mm howitzer, M185 155mm howitzer, M284 155mm howitzer. Secondary, .50 caliber M2 machine gun, Mk19 Mod 340mm automatic grenade launcher, or 7.62mm M60, M240 machine gun or L4 machine gun, railgun hypervelocity projectile. In January 2016, the U.S. Army test-fired hypervelocity projectiles originally designed for use by U.S. Navy electromagnetic railguns and found that they significantly increased the gun's range. The Army is looking into using the M109 Paladin firing the HVP for ballistic missile defense, as traditional missile interceptors are expensive and gun-based missile defense used for point defense would utilize artillery already in the infantry at a much lower cost per round. The HVP costs $25,000 per round and is capable of being fired out to 50 nautical miles from a conventional cannon. It weighs 68 pounds with a 23 pounds flight body containing its guidance and warhead. Less powerful but more agile to hit small, high-speed targets. Modifications will be needed for the Paladin to effectively shoot the HVP, possibly including different propellant to achieve higher velocities, automated reloading systems to fire quickly enough to defeat salvo launchers, improved barrel life, and a new fire control and sensor system. Variants: M109, first produced in 1963. It had a 23 caliber 155mm M126 gun in an M127 howitzer mount, and carried 28 rounds of 155mm ammunition. It was also armed with a 50 cal M2HB machine gun with 500 rounds of ammunition, easily identified by its short barrel and a double baffle muzzle brake with a large fume extractor just behind it. Maximum range of 14,600 meters, replaced the M126 gun with a longer-barreled 39 caliber M109A7 gun, increasing maximum range to 18,100 meters. Incorporated 27 reliability, availability, and maintainability mid-life improvements, most notably the long-barreled 155mm M185 cannon in the new M178 gun mount, ballistic protection for the panoramic telescope, counterbalanced travel lock, and the ability to mount the M140 alignment device. Stowage increased from 28 rounds of 155mm to 36 rounds. 50 cal ammunition remained at 500 rounds. During M109A2 production, a slightly simplified version was also produced for export. This had minor internal changes and deleted the hull flotation feature. These were designated M109A1B, M109A3 and M109A3B. M109A1S and M109A1Bs rebuilt to M109A2 standard respectively. Some A3s feature 3 contact arm assemblies, while all A2s have 5. M109A2S and M109A3S improved with nuclear, biological, and chemical reliability, availability, and maintainability improvements, including air purifiers, heaters, and mission-oriented protective posture gear. The traversing mechanism's clutch is hydraulic, as compared to the electric mechanism on previous M109s, and features a manual override in the event of an electrical failure. The A4 also adds an additional hydraulic filter, for a total of 2. Also included is an improvement to the engine starting equipment, greatly improving the ability to start in an emergency. Ammunition amounts remain the same as 2 previous models. Replaces the 155mm M185 cannon in an M178 mount with a 39 caliber 155mm M284 cannon in an M182 mount, giving the A5 a maximum range of 22,000 meters with unassisted projectiles and 30,000 meters with rocket-assisted projectiles. The vehicle can carry 36 complete rounds of ammunition and has a 440 horsepower engine instead of the standard 405 horsepower engine. M109A5 Plus. Various manufacturers have upgraded the fire control and other components of the M109A5. BAE Systems in York, PA recently delivered 12 M109A5 Plus vehicles to Chile. M109A6 Paladin. Overall product improvement in the areas of survivability, RAM, and armament. This includes increased armor, redesigned internal storage arrangement for ammunition and equipment, engine and suspension upgrades, and product improvement of the M284 cannon and and M109A7 mount. The greatest difference is the integration of an inertial navigation system, sensors detecting the weapon's lay, automation, and an encrypted digital communications system, which utilizes computer-controlled frequency hopping to avoid enemy electronic warfare and allow the howitzer to send grid location and altitude to the battery fire direction center. The battery FDCs in turn coordinate fires through a battalion a higher FDC. This allows the paladin to halt from the move and fire within 30 seconds with an accuracy equivalent to the previous models when properly placed, laid, and safed, a process that required several minutes under the best of circumstances. Tactically, this improved the system's survivability by allowing the battery to operate dispersed by pairs across the countryside and allowing the howitzer to quickly displace between salvos, or if attacked by indirect-fire aircraft or ground forces. Ammunition stages increased from 36 to 39,155 mm rounds, M109 kawesd. This Swiss improved version produced by Ruegg incorporates a new Swiss-designed L47 155 mm gun with an increased firing range of up to 36 km. The L47 155 mm gun is derived from the Swiss Bison Fortress gun's inertial navigation system coupled with a new gun-laying system and more ammunition storage. The KAWESD requires only 6 crew members instead of 8, and is able to fire 3-round bursts within 15 seconds and maintain a constant firing rate of over 1 round per minute. Technical modifications: increased firing range of up to 27 km, increased rate of fire, increased ammunition autonomy. New electrical system increases reliability, integrated inertial navigation and positioning system, increased mobility, day and night operations capabilities, effective fire suppression system installed, NEMP and EMP protection, camouflaged paint and netting. Upgraded Swiss PZHB-79 and 88 are known as respectively PZHB-79 95 and PZHB-88 95, jointly developed by the Dutch firm RDM and the German firm Rheinmetall. The M109L52 was first revealed in 2002. The main improvement was replacing the M126 series gun with the longer 52 caliber cannon from the PZH-2000. Thus the MTLS ammunition of the PZH-2000 can be used. In addition, improvements to the loading system were made. This resulted in an increase of the rate of fire to 9 to 10 RDs per minute from the original thirds per minute, and this high rate of fire can be sustained for up to 2 minutes. A total of 35 rounds can be carried. M109A3GNM, the current version in use in the Norwegian Army. Brigade Nord's Artillery Support Unit, Artillery Bataljonen, has 3 batteries using this. K55, K55A1 are South Korean variants of the M109, originally based on M109A2, with additional domestic augmentations. License produced by Samsung Techwin. They are fitted with NBC protection, automatic fire extinguishing system, and a modified ammunition reception module for K56 automatic ammunition resupply vehicle. The Performance Improvement Program variant, K55A1, is a complete domestic overhaul of the K55, which is further augmented by Samsung Thales with modern digital ballistic computers, multifunctional data display and controllers, GPS navigation and target acquisition system, wireless data link equipment, and upgraded fire control storage battery and power supply unit, to closely match the U.S. military's modernization of the Paladin into next-generation standard. Many improved technologies of the South Korean K9 Thunder were retrofitted on the K55A1. 1040 howitzers of these variants were produced. M109A7. The newest M109 version for U.S. service is the M109A7, formerly known as the M109A6 Paladin Integrated Management. The M109A7 shares common components with the Bradley fighting vehicles such as the engine, transmission, and tracks. This creates commonality with other systems and maximizes cost savings in production, parts, inventory, and maintenance personnel. The M109A7's onboard power systems harness technology is originally developed for the non-line-of-sight cannon. The electric drive is faster than the previous hydraulic system, and the automatic rammer more consistently rams the round into the gun for consistent velocities and better accuracy. It features a 600-volt onboard power system to accommodate additional armor and future networking technologies as they become ready. The M109A7 can sustain a 1 round per minute rate of fire and a maximum rate of fire of 4 rounds per minute. Weighing 78,000 pounds, the M109A7 is 10,000 pounds heavier than its predecessor, and it has a capacity grow to 110,000 pounds. Even with the weight increase, the M109A7 can travel faster than previous versions at 38 miles per hour and is more maneuverable than a Bradley fighting vehicle. Prototypes of the vehicle underwent government testing in preparation for a low-rate initial production decision. The testing included reliability, availability, and maintainability mission testing as well as ballistic hull and turret testing. M109A7 was slated to begin low-rate initial production by 2013. The U.S. Army plans on procuring a fleet of 580 sets of M109A7 howitzers and M992A3 ammunition support vehicles. In October 2013, the Defense Acquisition Board approved the decision to start M109A7 production. The FY 2014 budget called for $340.8 million in Paladin funding, which would be 24 vehicle sets at $14.4 million per vehicle. The Army plans to buy 133 vehicles in 66 1/2 vehicle sets starting in 2014. Although one M109A7 howitzer and 2 supporting M992A3 ammunition carriers will be destroyed during tests, a full-rate production decision planned for February 2017. On the 31st of October 2013, BAE received a $668 million contract to begin low-rate initial production of the M109A7. The first M109A6 and M992A2 vehicles were disassembled and reassembled to M109A7 and M992A3 standard as part of low-rate initial production beginning in summer 2014. Low-rate production deliveries began in April 2015. Derivatives: M992 to the Field Artillery Ammunition Supply Vehicle is built on the chassis of the M109 series. It is also colloquially referred to as a CAT. It replaces the M548 supply vehicle. Unlike the M548, it is armored. This ammunition vehicle has no turret but has a taller superstructure to store 93 rounds and an equivalent number of powders and primers. There is a maximum of 90 conventional rounds, 45 each in 2 racks, and 3 M712 copperhead rounds. Until recently, much of the remaining internal crew space was taken up by a hydraulically powered conveyor system designed to allow the quick uploading of of rounds, or transfer of rounds to the M109 series howitzer. Most early models had an additional mechanism called an XY conveyor to lift the rounds into the honeycomb-like storage racks in the front of the superstructure. A ceiling plate above the two racks can be unbolted and opened to allow the racks to be winched out of the vehicle. This vehicle is fitted with a Halon fire suppression system and a weapons mount similar to that on the M109 turret, usually mounting a Mk19 grenade launcher for local defense against infantry and light armored vehicles. The latest models have a mounting point for two secure radios. The hydraulic conveyor system is removed by crews as it is slower than moving the rounds by hand. Recently the Army has removed the conveyor system and changed the two horizontal opening doors to two vertical doors opening from the center to provide protection to the crew during transfers. The vehicle also contains a two-stroke diesel-powered auxiliary power unit that can power all non-automotive energy requirements on the field, artillery ammunition supply vehicle and on the howitzer when a slave cable is used to connect the two. This reduces fuel consumption when mobility is not required. Training systems. The U.S. Army uses the Fire Support Combined Arms Tactical Trainer in two versions for initial and sustainment training of the M109A6 and M109A5. The system uses an actual surplus turret and a simulated ammunition system. The Swiss Army uses a highly advanced KAWESD trainer from Van Hulteren Metal of the Netherlands. The Dutch, Belgian, Thai, and Israeli armies have various configurations of the Van Hulteren Metal LARIT M109 trainer. Operators. Current operators: M109 Libya, M109A1 Djibouti, 10, Ethiopia, 17, Greece 51A1B, Iran, 440, Kuwait, 5A1B, Morocco, 44 M109A1B, Oman, 15AO, Peru, 12, Switzerland, 224, United Arab Emirates, 40. M109A2A3 Brazil, 40A3 Brazilian Army, Denmark, 2-6, Greece 84A2, 50A3 GEA1, 223A3 GEA2, Egypt, 400A2, Italy, 221 M109L, Jordan, 356A2, A2-90, Lebanon, 12A3 plus 22 TBD, Morocco, 78 M109A2, 22 M109A3 and 40 M109L47, Norway, 14 M109A3 GNM, Pakistan, 150 plus A2 in service with the Pakistan Army, being upgraded to M109A5 standard. Portugal, 6A2 since 1981. Currently retired from active service and being used only in training duties. Saudi Arabia, 60 A2s are currently being upgraded to A5s. Spain, 6, Tunisia, 1920 A2. M109A2 A5 Austria, 80 A2 A50. Republic of China, 225. M109A4 Belgium, 64 A4BE. Morocco, 4 M109A4. M109A5 Brazil, 36 surplus U.S. Army on order to be upgraded to M109A5 plus. Chile, 48 12A3 and 12A5 plus upgrade to similar Paladin configuration. Egypt, 201. Saudi Arabia, 36. Iraq, 24. Israel, 600. Pakistan, 115. Portugal, 18 since 2002. 14 of these vehicles were M109A2A3 upgraded to A5 variant. This variant replaced the previous 6 M109A2 operated by the Portuguese Army. Thailand 20, Greece 12, Spain 96, Morocco 60, M109A6 Paladin United States 929, Malaysia 30, K55, K55A1 Republic of Korea 1040, K55, K55A1 former operators M109A2A3 Belgium 127A2, of which 64 were upgraded to the A4BE standard, the remainder being decommissioned. Germany 570 A3GEA1A2, phased out by the 1st of July 2007 and replaced by the PZH2000. Netherlands 126 A290, phased out and largely replaced by the PZH2000. United Kingdom 140 plus entered service in 1965, upgraded to A1 and A2 standards, and eventually sold to Austria in 1994. M109A4 Canada 76 A4B plus, phased out from the Canadian Forces since 2005. They were used between 1967 and 2005. All the vehicles had been modernized to the M109A4B plus SPH standard in the 1980s. They were primarily used by the 4 Canadian Mechanized Brigade Group in Germany.